Hi, this is Matt McCormick. I'm in the Department of Philosophy at California State University, Sacramento. This is my second lecture on Daniel Kahneman's chapters 26 through 29 in his book Thinking Fast and Slow. Today, in this lecture, I'm going to focus on something called the fourfold pattern and two interesting phenomena in human decision making that he calls the certainty effect and the possibility effect. And again, like we saw before in some of the other research, what Kahneman and Tversky did is they spent decades devising really interesting examples and test cases to give people choices. And then they documented what sorts of choices they would make, and very often they would exchange or test people's risk or their ability to sort of commit to a prospect with money and with the prospect of gambles. So let me use a couple of these sorts of examples to illustrate another really interesting nuance and wrinkle in the way that people make their decisions. One of the big stories here is that, not surprisingly, humans treat small probabilities as bigger. They have more hope than they should about them, and they treat very high probabilities as not being as good as they should. So that is, people are bad at probabilistic thinking is the sort of the net lesson here, and that comes out really acutely in this distinction between the certainty and possibility effect that Kahneman runs through. So imagine, if you will, let's tap into your system one and see what you think about this prospect. So first, imagine that you've got a 1% chance to win $1 million tomorrow. We're going to do a lottery draw. You've got 1 in a million tickets, 1 in 100 tickets, and if you win, you get $1 million. Okay, now imagine that you're almost certain to win. You've got a 99% chance to win $1 million tomorrow, but there's a 1% chance that you won't win. Okay, so picture the two situations. One is you got a 1% chance of winning $1 million, and the other is you're almost certain to win it tomorrow, but there's a very small chance, maybe a 1% chance, that you won't get it. Okay, now imagine yourself going through those two emotional states, or those two prospects, and now which is greater in magnitude? In the first case, you're feeling hope and optimism and excitement, and in the second case, you're feeling anxiety. Which one's worse? Which one's bigger? Your hope of winning in A, or your anxiety in B of perhaps not winning? Now, what Kahneman and Tversky found when they devised lots of examples to get people to make choices like this is that they discovered that people's worry, their anxiety about the prospect of losing something that was almost a certainty, that's much greater than the amount of hope that they weighted or that added to the small possibility. That is, the worry of losing it, of not getting it in the second case, is bigger than the hope of getting it in the first case. Here's what Kahneman says: the decision weights. Okay, so the decision weight is a measure of psychologically how much value do you subjectively put on the thing that's going to happen. And they devise some ways to measure this and sort of proportion it and figure out, well, how much weight is somebody putting on a percentage point, for instance. So the decision weights that people assign to outcomes are not identical to the probabilities of these outcomes. That is, we weight them higher or lower than the actual probabilities are, contrary to the expectation principle. And again, this is some evidence that seems to undermine the idea that expected value theory predicts really well what humans do. So, not surprisingly, improbable outcomes are overweighted. That is, if it's a very small chance of something's happening, we treat it as if it's bigger. Think of lottery tickets, right? Somebody goes and buys the lottery ticket, and it's got this astronomically small chance of winning, but we think of it and we treat it and we attach a decision weight to it as having more weight than its actual probability, which is very small. Outcomes that are almost certain, That is a case where it's almost absolutely certain to happen, but there's some small prospect that it won't. We underweight those. So you take that thing that you thought was almost certain and we treat it as if it's much less. We treat it as if it's not certain or not close to certain. The expectation principle by which values are weighted by their probability is poor psychology. So what Kahneman means there is that the expected value, which in my picture on the upper right-hand corner, expected value, just like in one of the last charts we saw in the previous lecture, if we were attaching a proportional amount of weight to our decisions that matched their probabilities, then the line would be a perfect 45-degree angle running from lower left-hand corner to top right-hand corner. If we had if your amygdala, if your emotional system, if your worries, if your hopes weren't distorting your sense of probabilities, you'd have that perfect line distribution where you treated a 1% chance of something's happening with 1% decision weight, and you treated something that was a 99% chance of happening as having 99% decision weight. But actually what we do is we inflate small percentages and we deflate high percentages. So that's what that curved line, that blue curved line is, that's on that same chart, that goes up at the bottom, up in the lower left-hand corner, and then goes down on the upper right-hand corner. So you've got this nice S-curve that describes the way people systematically distort low and high probabilities. We take low ones and we push them up, and we take high ones and we push them down with our weights. And the chart on the bottom right-hand side shows the same thing. It just shows the data that shows the same information. So we've got in the top row, we've got probabilities ranging from 0 to 100. And in the bottom row, we've got decision weights. How much psychological value or how much weight do you put on it personally, subjectively, ranging from 0 to 100. And you can see, I'll just point out a couple of really interesting things about this. So look at the probability column, the second column, for 1%. Take an event that's 1% likely to happen, like be struck by lightning. How do people weight that? How do they treat it? How much do they inflate that 1%? You go down the column, and what it says is 5.5%. So they act as if a 1% chance of something's happening is actually 5.5% probable to happen. Okay, so roughly 5 times higher. Now go to the other end of the spectrum. Take something that has a 99% probability of happening. How do people treat that decision when they make, how do they weight that kind of decision when they make their choices? They treat that 99 as if it's only 91.2. So they deflate that 99 down to 91. They reduce it by like 8 percentage points. Okay, so that's to say that for a very small probability of something happening, like the lightning striking, we inflate that some. But for something that's almost certain to happen, but there's some small chance it won't happen, we worry about that a lot and we weight it heavily. We treat it as if it's much lower than it actually is. That is, the 1% change at the top is weighted much more heavily than the 1% change at the bottom of the spectrum. And that's what the S-curve shows, because the S-curve is not only is it just an S-curve, but it's also shifted to the left. You can see that the curve swoops down much more on the right-hand side and the left is smaller. Interestingly, where do those two curves intersect? And what that is the answer to is this question. Where are people good at estimating probabilities? When people are faced with different probable outcomes, and the probability of the outcome is ranging from 10 to 20 to 40 or 50% probable to happen, when do people weight it appropriately and get it right? And interestingly, the answer to that question on this chart is at 35%. When something's 35% probable to happen, you weight it about 35%. You don't inflate or deflate it at all. You act as if, and you make choices as if that's about what's likely to happen. You might have predicted that 50-50 is where we'd do this, but actually it's 35%, which is a really sort of strange inversion. But what it also does is that this is another way of communicating that information we were looking at in the last lecture about loss aversion, right? You worry, there's negativity dominance, and you worry about the prospect of a sure thing. You know, maybe you're safe and secure in your home, but there's this tiny chance that something bad will happen to you. You act as if it's a big chance, right? But if it's some very low probable thing, it's not very realistic. It doesn't seem, it's not prevalent, not in front of you. You don't think of that as, you don't inflate that as much. I should think some more about how this applies to coronavirus fears since we're in the midst of that pandemic, but I haven't really looked at or thought about how that applies and how people's behavior acts here. There's going to be data and empirical information that psychologists like Kahneman are going to be able to use for decades to observe human behavior. Okay, so what would the value curves of the expectation principle and for the possibility certainty effect valuations look like in contrast? The red line there is what expected value predicts. The blue line is what humans actually do. Okay, so what we've seen now is that fear is greater than hope once again, and negativity dominates. Okay, so what this happens is, what's going on here is that prospect theory differs from utility theory in the relationship it suggests between probability and decision weight. So utility theory would have just put those as the same, probability theory, or probability and decision weight. In utility theory, decision weights and probabilities are the same. The decision weight of a sure thing is 100, and the weight that corresponds to a 90% chance is exactly 90, which is 9 times more than the decision weight for a 10% chance, and so on. That's the way econs, or sort of perfect mathematical robots, would act if they were making choices. But with humans and in prospect theory, variations of probability have less effect on decision weights. The decision weight for a 90% chance was rated at 71.2%, and the decision weight for a 10% chance was at 18.6. So people have got sort of screwy and skewed sensibilities about what probabilities are when they make their decisions, and they rate the near certainties, or the high end of the spectrum. There's a bigger effect, or a larger effect than at the bottom. So that is, the certainty effect is bigger than the possibility effect. Not only are the decision weights different than their probabilities at the low and high end, the weighting isn't symmetrical. That's our 35% issue. We distort the weight of the probabilities of near certainties more than we distort low possibilities. Okay, so what are the lessons here? Well, when you're dealing with other people, predict their behavior according to the possibility and certainty effects. People are going to do that. People are going to make decisions, about gambling, about choices, about prospects, about bad things that might happen, good things that might happen, losses and gains. They're going to treat them and weight them according to that blue S curve that we just saw. For bad outcomes, we can predict that people will worry too much about tiny possibilities. They worry about sharks, for instance, when they're sitting on the beach, even though there's sort of only 1 in 500 million humans every year eaten by sharks. For good or unlikely outcomes, if we focus on them, we weight them too heavily, and that's what's going on with the lottery tickets, obviously. When you're trying to make the best decisions you can for yourself, know that you tend to overweight small possibilities and that you undervalue near certainties. So know that you're prone to think and decide according to that blue S curve. So you're inflating or deflating, depending on whether we're talking about a low possibility or a near certainty. And the latter is proportionally larger. Certainty effect is much bigger. What do you do to fix that? Well, first off, just notice that we're doing it, and then we got to try to adjust and sort of get our value decision weights to sort of map onto what the actual probabilities are a bit better. Okay, so the other really big and more complicated set of concepts I've got to explain today is this fourfold pattern business. Okay, so in many ways, this is yet another way to present some of the same information, but it comes out in a much more sort of complicated and sort of technical way. Okay, so the fourfold pattern's a way to represent the 4 quadrants, in effect. Is that right? No, that's not quite right. But if the fourfold pattern's a way to represent that information we saw in that prospect theory graph before. Okay, so here's what's going on in this sort of complicated graph. So the first row in each of these 4 quadrants just outlines what the prospect is. What is the thing that might happen to you? So in the upper left, suppose you're facing a 95% chance to win $10,000. In the lower right, suppose you've got a 5% chance to lose $10,000. So let's look at gains and losses and high probabilities and low probabilities, and that gives us a quadrant of 4. So the first row is just, here's the sort of prospect that people in the research were faced with, a small chance or a high chance of winning or losing. And then the second row describes the emotion, or in many cases, the amygdala response that's provoked by the situation you put somebody in. Okay, so give somebody a high chance or a low chance of a gain, and they're going to feel something about it. Or give somebody a high chance or a low chance of a loss, and they're going to feel something about that. So that's the second line in all of these 4 quadrants. They're going to have fear, they're going to have hope, fear and hope in both cases. Third row, how do they act? Given this strange set of distortions, or these ways that people skew probabilities and the way they feel about it, what do they do? Okay, so we've got the 4 quadrants explain that in the top left, they're risk averse. The top right, they're risk seeking. In the bottom left, they're risk seeking. And the bottom right, they're risk averse. That is, if I were to give you a series of choices that reflected, say, a 5% chance of losing $10,000, and I gave you options to maybe be risky and act in ways that could possibly get you out of this big loss, you would be, your risk aversion, let's see, make sure I get this right, you got a 5% chance of 10% of losing $10,000. You're risk averse. So I got that backwards. The kind of, like I said, this thing's really complicated and technical. Let's consider the lower left-hand corner instead. Suppose you're faced with a 5% chance of winning $10,000. You've got all this hope for large gains, and you get risk seeking. That's sort of like lottery behavior. That's where you go after things. You like those prospects because of the way you feel about gains, but you're more averse to losses. The fourth row in these 4 quadrants describes defendant and plaintiff behavior in civil cases. So one of the places where this phenomena is revealed in human behavior is when you've got, and you can look at lots of data, is when you've got people suing or people engaged in different civil cases in court, and they're either faced with getting a big settlement or they're faced with getting a big loss, and you've got defendants and plaintiffs on both sides, and how they act actually maps onto this chart that shows this fourfold pattern. So the bottom left, as I said, captures lottery ticket behavior. That's where people will, because they're inflating that tiny probability and they're treating it as bigger, they'll go buy lottery tickets, right? This is how state lotteries are making so much money off of state-run lotteries, is that people will pay more money for a lottery ticket than their actual expected value, and the state reaps that extra benefit, right? So a lottery ticket costs you $3.50 or $4 or whatever it costs. The actual expected value of that lottery ticket, given the probabilities and the utilities, the expected value of that thing is way worse than $3.50 or whatever it is you paid for it. And the state runs the big numbers here, so they have millions and millions of people buying tickets, and they skim the difference. So they actually exploit that S-curve on that low end of the diagram from the previous slide. They're able to get people to behave in ways that they'll act according to that blue curve, and they make up all the difference, right? They skim all that extra. And then, importantly, the bottom right captures insurance buying fears, right? So people, when they're worried about, loss or breakage or theft or something breaking down or what have you, this is like the examples I've given you from you buy a laptop and Apple offers you an extra a product replacement or protection plan, and they're going to charge you $79 for it, or $199 for their full coverage for 3 years. Well, you think about the low probability But there's a non-zero probability that you'll break it, you'll lose it, or it'll get stolen, and you inflate that, and you act accordingly. You decide that. You treat it like, maybe there's a 90% chance. Let's make sure I get it right. Maybe there's only a 5% chance that you'll lose the laptop, but you treat that as if it's more, and then you're willing to pay more money as a result. So Apple, or the company that they contract out to that sells you the insurance, they skim that difference off, right? So in both cases, in lottery cases, the state is skimming off the difference of your decision weights being out of whack with expected value. And in cases of insurance buying, the insurance company is skimming off your willingness to pay more than it's actually worth and your deviation from expected value there. So there's lots of profit being made off of these strange bulges in these distortions in people's probability estimations. Okay, so more about legal cases. Imagine you're the plaintiff in a civil suit where you've made a claim for a large sum in damages. Maybe there's lots of cases where, product liability cases where somebody gets hurt and then they sue the company because they got hurt over the use of the product. Some of the famous cases are kids in pajamas that aren't flame retardant, or there's medicine bottles that don't have, or used to not have, childproof caps on them. Those kinds of cases, right? So suppose you're the plaintiff, so you're the one who's going after the big company trying to get some money for the damages that happened to you. Imagine those kinds of cases. When the trial goes well, then it looks good for you. The night before the decision, your lawyer says there's a 95% chance that you'll win, but you never really know. There's a 5% chance you won't. Okay, so now here's you the night before you're about to get $1 million. And there's a little chance, there's a 5% chance that you won't get $1 million. So what does the fourfold pattern tell us, and what does this decision weight graph tell us that person's going to be like? What's their behavior going to be? Here's you the night before, you're about to get a whole bunch of money. It's an almost certain outcome that you're going to get all that money, but there's a small chance you won't. What do? You inflate that small chance that you won't, and you think that the prospects of you getting that big settlement are worse than they actually are. So you worry more than you should, you deflate it more than you should, and you've got this sort of amygdala response that's making you sketchy. It's making you stressed about the situation. Well, anytime you got people who are sketchy, whenever somebody's having that kind of amygdala response on here, not surprisingly, here's a place where some big company or somebody can come in and make some money, right? We've seen that the lottery, the state will come make money off of you through the lottery ticket behavior, and this is going to work just like insurance buying cases. What happens in these kinds of cases is that the other side's lawyers, especially if they know about this phenomena, they're going to come to you and they're going to make you an offer. They work for Dow Chemical or whoever it is that made your kids' pajamas. And Dow Chemical knows what's going to happen to them, and they're in the business of, they've got 100 of these lawsuits going on, so they're playing the big numbers, just like the casinos are playing the big numbers, just like the state is playing the big numbers, and just like insurance or companies are playing the big numbers. So they say, and they see, oh shit, there's a 95% chance we're going to lose this case tomorrow if we go ahead and go to a jury decision, for instance. So what they do is they send their lawyers the night before and say, okay, I will give you 90% of the settlement you're asking for. So you've got a 95% chance of getting $1 million. Well, we'll give you $900,000. And notice you're the one who's in the sketchy, worried position because you're worried about the prospect of this uncertain thing happening. And we know that the certainty effect is greater than the possibility effect. So it's going to work against you in this case. And you think to yourself, well, am I willing to take even a small chance of getting nothing at all? I mean, there's a 5% chance tomorrow that I'll get nothing. So that person's too worried, and the emotions amplify this issue they're in. And what they end up doing is that they very often settle rather than risk it, even for tiny risks. And the other sort of sneaky part about this is that if you're the corporation and you're making your decisions sort of cold and rational and strictly according to the numbers here, the other thing you do is you have them sign a non-disclosure agreement so they can never talk about it. So not only do you save $50,000 as the company, but you get a non-disclosure agreement out of them, and they can never say what happened, or whatever. If you're, the subject of some child abuse suit or something like that, right? So the asymmetry of the possibility effect and the certainty effect, they work against you in this kind of case. One's being bigger than the other. Okay, now let's flip the cases around. Imagine the other way around. Imagine that you're the defendant in the same case. So the trial is going poorly, and you can see I'm going to lose here. But you still got some hope. You still, this is you making the decisions as an individual. And I think what happens very often is that when you've got corporations and whole teams of lawyers and teams of statisticians and people setting policy, like at a casino, we can mitigate some of the sort of emotional variations of the way individual humans will make decisions. So in the cold, thoughtful reflection of reason, if I'm a casino and I'm setting policy for how to set up my slot machines, or how to, arrange the tables, or how to arrange the games, I'm going to make a very different sort of decision if I'm playing the big numbers than if I'm just a person, an individual who goes in the casino and is playing and feels the rush and has the adrenaline excitement of winning, or the pain of losing. So when you get companies like that, or when you get organizations like that can make decisions on a grand scale, and they can aggregate, they can make a more thoughtful, large-scale policy decision that works to their advantage and works more like expected value would work, that leverages against the individual nuances where we see, a single person making a decision is prone to inflate low probabilities and deflate high probabilities. Okay, so now we're flipping the case where it's just you as the defendant, somebody suing you, and it's not going well for you. It's not looking good. It looks like you'll probably lose. The plaintiff's lawyers proposed a settlement in which you pay 90% of the original damages. Okay, so the trial is going poorly again. Let me make sure I got this right. Oh, I stated this the wrong way. I didn't read my own notes carefully enough. This is the defendant, and the defendant is winning. The trial is going poorly against you, but you still have hope. The plaintiff's lawyers, the people coming after you, have proposed a settlement in which you pay 90% of the original damages. Do you settle, or do you risk the jury decision? Now, you face a high probability of loss. This is the top right of the fourfold pattern. Okay, so this is the case where you're probably going to lose. Sorry, I've mixed those up. You're probably going to lose, and you've got a high probability of loss. Do you settle in that kind of case? The temptation to fight is really strong. 90% settlement is almost as painful as 100%. Imagine somebody at the corporation side, considering, what do I do? Suppose somebody who's in charge of making that decision on the corporate side, they look at the case and go, oh, there's a 95% chance we're going to lose tomorrow. Well, maybe we should give them 90% and cut our losses. Personally, you'd be tempted to fight it. That is, 90% settlement is almost as painful as 100%. Sure loss is repugnant to you. A tiny possibility of winning is highly attractive. You'd like that. That's sort of your ego kicking in. But a defendant with a weak case is likely to be risk-seeking, prepared to gamble rather than face a certain smaller loss. In the face-off, the defendant holds the stronger hand in this kind of case, because they're losing, and the possibility effect is smaller than the certainty effect. Works the other direction. Okay, so that captures the sort of the nuances, and Kahneman's got a bunch more of the four sort of quadrants to look at the way gains and losses and certainty and probability affect and distort the way people look at probabilities in their decisions. And it maps or connects up to the prospect theory stuff we've been looking at, and the loss aversion and the negativity dominant stuff we've been looking at too. Okay, so that wraps up what we've got to say about chapters 26 through 29. We've considered all the details about prospect theory. We've talked about loss aversion and the endowment effect. We've talked about negativity dominance. We talked about Jack and Jill and goals as reference points. That's one of the new innovations of Kahneman and Tversky's approach. And we've talked about this notion of maybe, there being evolutionary pressures to lead us to have this status quo bias or have this preference or defend the status quo. And now we've looked at the fourfold pattern, and we've looked at this distinction between the certainty effect and the possibility effect and the way it changes people's decision weights with regard to probabilities. Turns out expected value theory doesn't map well onto what humans do. They actually deviate from what expected value theory would predict.